Hello students and good evening. How are you? I hope all of you are well and you had a very good day today, and I suppose you are ready, completely ready in fact, to continue our discussion in distributed systems. So we have 15 slides to finish this chapter. In this session, I hope I finish this chapter, and next session tomorrow at 6 o'clock we will start chapter 2. Well, in the last session we talked about some pitfalls or wrong assumptions of first-time developer in distributed systems. The network is reliable, the network is secure, of course not. The network is homogeneous, and so on. These are false assumptions made by first-time developers, so please be careful about it. Types of distributed systems. In general, we have 3 types of distributed systems. The first type of distributed systems are distributed computing systems. The second type is about distributed information systems. And lastly, distributed pervasive systems. Let me talk about these types of distributed systems in detail. The first one, distributed computing systems. Many distributed systems are to compute and to calculate and to solve some problems. For example, if we provide many distributed systems and machines for high performance computing, HPC, high performance computing, we can use some parallel computing techniques to solve heavy problems. It is cluster computing. It is cluster computing. Essentially a group of high-end systems connected through a LAN, local area network. As you can see, look at here, cluster computing properties. Homogeneous, same operating system, usually same operating system in different machines. Near identical hardware, it means same hardware. And single managing node. There are many different machines in a building. They are connected through a LAN, and we have one machine to manage this cluster. It is called cluster computing. Please note, it is not parallel computing with supercomputing. Supercomputer is a computer consisting of thousands of processors. It means supercomputer is a multiprocessor system in fact. But cluster computing, in cluster computing we have different machines, different computer systems. Each computer has operating system, its CPU, its memory, and its file system. So it's not supercomputer. Cluster computing is using different computers, connect them through a LAN to calculate heavy problems. In this system, we have one computer in which this computer is responsible to manage the cluster, the whole system. Clear? Very good. I'm looking for a file to show you. Please wait a moment. I'm not sure if I can find it or not, but I can try to find it. Okay. Here, in this picture, you can see a cluster computing, cluster system. As I said, we have different computer nodes. The first node is master. It is responsible to manage all the computers, all the cluster here. And as I said again, each computer has its local operating system and other parts of machines. Computers are connected through a network, usually local area network. So this system is implemented in a building and it is used for parallel computing purposes. As you can see in master node, we have parallel libraries. Parallel libraries are some libraries to manage parallel computing. For example, how to break the problem into subproblems and how to gather the results, how to send order to other computer nodes to start computation, and other controls of parallel computing. Good. Another example of such systems, distributed information systems are about grid computing. When in a cluster, when we distribute computers to different locations, not in a building, different areas, and we use WAN instead of LAN, we will have grid computing. Got it? We distribute all the computers and machines to different locations, and we use WAN, wide area network, instead of LAN. Then we will have grid computing. In grid computing, we have heterogeneity. Heterogeneity means the hardware and the operating systems are not the same. Dispersed across several organizations and can easily span a wide area network, as I said. Any question? It's very easy, I think. Very, very easy and obvious. In Greek computing architecture, we have four layers. Application layer, which is the top layer, collective layer, connectivity layer, and resource layer. These two are in one layer. And fabric layer, which is the lowest layer, bottom layer. In application layer, as the name implies, we have some applications to request resources, to see the status of resources, and to free the resources, to lock the resources, especially in databases, to lock tables when we want to modify table, we want to remove, we want to update, or we want to add new record in table. We must lock the table. So, in application layer, we can do such tasks. The collective layer consists of some protocols, communication protocols, in fact, to support network transactions. So, it is called collective layer. Resource layer is manager of resources. The name exactly explains that this layer is for managing a resource. And fabric layer is about scheduling. When we have different users or different requests and we have only one limited and shared resource, or our shared resources are limited and our users or our requests are very much, so we need to schedule. Do you know what is scheduling? I consider that you are familiar with scheduling if you have passed operating system in your bachelor. Scheduling algorithms, for example, FIFO, first in, first out. For example, round robin. Yes? Okay. In single processor scheduling, we have one CPU, we have single CPU, and we have many tasks. We have many applications, they want to be executed, okay? So, we must schedule. For example, at time 0, task 1 can be run on the CPU. And at time 5, we can assign task 2 to the CPU to be executed. It is scheduling. So in fabric layer, scheduling about resources is done. And distributed information systems, they are called transactions. It is the second type. Let me back to this slide. We are talking about types of distributed systems. Cluster computing and grid computing are types of distributed computing systems. The second one is about distributed information systems. They are called also transaction systems. What is transaction? Transaction is a collection of operations on the state of an object. This object can be database or other things that satisfies the following properties. These four properties are called ACID. A-C-I-D. It's not related to acid. Don't confuse with acid, okay? It is called ACID because each character is the first character of each property. A stands for atomic, C stands for consistent, and I stands for isolation, D stands for durability. Do you know what is transaction in fact? What do you know about transactions? Have you worked with databases? Have you programmed for databases? Yes or no? Okay, I try to explain it in a simple way. Consider we have a database. Our database has different tables about some information. For example, one table is about identity information, name, family, birth date. And the other table is about some financial records. Okay, so when we want to read or to write a new record in the database, it is done by a transaction. Transaction means all the operations that we need to, for example, write a new record to database, or to delete a record from database, or to update a record in the database. It is transaction. So each transaction has at least four properties. These are four properties of transactions. Atomic. To be outside world, the transaction happens indivisibly. We cannot divide it. We cannot divide transaction into two parts or three parts. No, a transaction has only one part, to the outside world, when we see in outward. It means a transaction cannot be finished or cannot be completed when, for example, it is not committed. I mean, you cannot do a transaction by half. All the transaction must be finished or nothing will occur. For example, if you want to transfer money in online banking between your accounts, okay? If you want to transfer money from account 1 to account 2, it's a transaction, okay? This operation will have two conditions. Condition 1, all the operation is done correctly. The operation finishes completely. And situation 2, nothing happens. Nothing happens. We cannot do 50% of this operation. We cannot do 50% of this transaction. It's about transferring money. All or nothing. It is called atomic. We cannot divide it to 2 or 3 parts or more parts. Why we use this word? Why we say it is atomic? Why atom? Why do we use this name for this property? Because we cannot break and divide atom in different parts in real world. Atom is the smallest part of every object in our world. So it is not possible to divide it to 2 or 3 subparts, okay? The other property is about consistency. It means before a transaction is done and after it is done, the database is in a consistent state. It is called consistency. Isolation says that we can serialize transactions. For example, suppose that in online banking, different customers want to transfer money. They want to access to the database at the same time, simultaneously, okay? So we have some transactions that they want to access and to do something on the database at the same time. We must be able to schedule this transaction and set them in a queue. Queue means saf, in a queue. For example, transaction 2 first, and the second transaction is transaction 4, and the third transaction that must be executed is transaction 3, and so on. It is the meaning of isolation of transactions. In other words, isolation means that transactions are not overlapped with each other. Lastly, durability is another property of transactions. Durability means once a transaction commits, it means when it finished successfully, the changes are permanent. For example, when you want to transfer money, once your operation is done, the result is permanent. The result is saved, stored in the database forever. It is the meaning of durability. That's it. Was it difficult or easy? (50-50). So I strongly recommend you to read the book after the class finished. Okay, after the class finished, go and open your book and read and study this part in your book. Do you have a book? I hope all of you have book because it's very important for you to understand to understand lesson. If you can understand the lesson while you are listening, it's okay. You don't need book, okay? But if you have problems or you have some difficulties understanding the lesson while you are listening, it is crucial for you to use your book. Okay. Transaction processing monitor. Here we can see TP monitor. TP monitor is teleprocessing monitor. What does it? What does it? What does teleprocessing monitor do? Okay. Suppose we distributed our data to different servers. So we decentralize our data. I mean, we have one database, but each table may be stored in different location, different server, okay? In such situation, when a transaction is going to be executed, we need a TP monitor or teleprocessing monitor to control the transfer of data between multiple terminals. Here, terminals are server and client application. So, a teleprocessing monitor or TP monitor is a control program that monitors the transfer of data between multiple local and remote terminals to ensure that the transaction processes completely. Or in some situation, if an error occurs, to make appropriate action related to the occurred error. So in this condition, we need TP monitor. Also, TP monitor can control the transfer of data between different terminals in a distributed system. It doesn't separate applications from their databases. So, if we want to find some methods to make a communication between clients or resources, we need some methods such as RPC, RMI, and MOM. RPC or remote procedure call. What is it? Suppose we have some different users and they want to make a communication to each other, okay? Remote procedure call is using a remote call of a procedure on the destination. For example, we have a printer, the printer is shared and we have some users here in this room, okay? So if you want to use the shared printer to print a document, what you do is that to call a procedure on a system or on a computer that the printer is installed on it. We have a shared printer. This printer must be connected to a computer. The computer is shared on a network, so it is visible by other users. But we have a computer here that the driver of the printer is installed on it. So the only job that you should do is that to call the procedure of printing on a destination computer that the printer is installed on, and then send your document to be printed. It is remote procedure call. Was it clear? Do you want to give you more explanation? Oh, sorry, I was disconnected for a few seconds, I think. Can you hear me now? Is it okay? Okay. And the last type of distributed systems are called distributed pervasive systems. Distributed pervasive systems. Again, let me come back to this slide. Here, we are talking about different types of distributed systems. We talked about distributed computing systems. Two examples are cluster computing and grid computing, The second type of distributed systems are distributed information systems. They're called transactions. We talked about transaction systems a lot. And the last type of distributed systems are distributed pervasive systems. Pervasive means متفرقه or جامع, I think. It is better, جامع in Arabic. We say فراگیر in Farsi. It is جامع. Okay. Distributed pervasive systems. Here. The previous distributed systems are those systems that are stable. They are placed in one location and the communication is stable. But there are some systems that are mobile. They are sayyar, okay? And some properties of such systems are that those systems are small, usually. They are small, they are mobile. It means متحرك, mobile. And they are often embedded in a larger system. Embedded. Embedded means نهفته. I don't know what can we say in Arabic, but it's embedded. It means you embed some systems in a larger system. متضمن maybe, I don't know. My Arabic is very poor, really. And تعبیه شده means maybe good, maybe is a good definition for embedded system. I'm not sure. Yes, system inside a system. Smaller system inside a larger system. Let me give you an example. Suppose all of us have television in our home, okay? And what is television? If we want to define a television in 3 decades ago or 2 decades ago, 20 years ago, we can say it is a device to see some movies, films, and it's a television, okay? But now, modern televisions are not just television. You can use to connect your television to the internet. You can browse the internet, and In a small word, we can say that our televisions have become a computer. It's not only a television, it's a small computer. Okay, you can use your television to store some files, some games. So it is a computer. It means we have embedded a computer in a television. It is embedded system, okay? We have embedded a computer in the television. It's embedded system. We have the same example for mobile phones. In two decades ago, mobile phones were only mobile phone. The people used the mobile phones to call their family, their friends, just it. But now our mobile phones are not just for calling and receiving calls or sending text. We can have different applications on our mobile phones. Internet browsing, we can connect to the internet. We can use our mobile phones to play game. We can use our mobile phones to take photo. So it's camera. In short, we can say that our mobile phones are small computers. It means that we have embedded computer in the mobile phone. Our mobile phone has operating system. Our mobile phones has CPU. Our mobile phones has its memory. It's a computer, in fact. So we have embedded a computer into mobile phones. It's embedded system, okay? It is the definition of embedded system. So, some requirements about these pervasive systems or embedded systems. Contextual change. The system is part of an environment in which change should be immediately accounted for. Ad hoc composition. Each node may be used in a very different ways, and sharing is the default. This is important. Sharing is the default in these systems. You can easily connect your mobile phone to the internet. It is very easy for you. You just turn on your mobile phone. Your mobile phone is connected to the mobile network, and then if you want to use internet, you can turn on your data connection. It's easy, and you will be added. Your mobile phone is added easily to the network. So sharing is the default. As you can see, nodes come and go. It's usually embedded systems. Okay, clear? Can I go to the next slide? The good news is that we are at the end of lecture 1, so we are finishing it. Okay, it's very good. Here you can see some examples of distributed pervasive systems. Home systems like smartphones, smart TVs, I talked about it. When we use our mobile phone, smartphone, is it a part of a network? And it's a distributed system. In fact, And other example is about electronic health system, or EHS. EHS, electronic health systems. If I want to talk about electronic health systems, I can show you this image. If you look at this image, you can see we have a patient here. Patient, ill person in a hospital, for example, patient, okay? And we can use different sensors, for example, to monitor blood pressure, to monitor the level of sugar, to monitor the number of breath, and so on. It means health condition, to monitor health conditions of a patient. It is called healthcare systems. These sensors are a part of a network. They are connected to each other. We have some processors, and we can send the data to a database, to a master computer. We can use GPRS network, for example, mobile data network, for example, to send the data to master computer. The master computer can collect the information and to monitor the condition of the patient. If we have an emergency conditions, then the system can call some doctors to inform them. It is healthcare systems. It's a pervasive systems, in fact. It's an embedded system, in fact. And it's a type of distributed systems. Was it clear? Could you understand completely what is healthcare systems? If you have some problems, please feel free to ask me, okay? I can give you more explanation. Why do we use healthcare systems? What's the main goal to use healthcare systems? What is the main goal? What do you think? What do you guess? What we use it? Yes, in order to monitor the patient's conditions. But why we want to monitor the patient's conditions? Yes, it's true, Zia. Yes, it's true. It's used to help the patient to feel free to go out. It means we don't want to stay the patient in the hospital. If a patient needs to be monitored, the conditions of the patient must be monitored, okay? We can stay him in a hospital to monitor the conditions. If we need emergency needs, we can help him. So we need to keep him in the hospital. But in this case, when we use healthcare system, we can monitor the condition of a patient while he is not in hospital. The patient can go home, can do his routine tasks, okay? Can go out, can go picnic, I don't know, can go travel. And we can be aware of his condition. So it is the main goal of healthcare systems to prevent from keeping the patient in the hospital. So, if it is our main goal, we must try to use healthcare systems in a way that this system must not annoy the patient. The patient must feel comfortable to do his jobs. For example, the sensors and the way that the sensors are installed on the body of the patient must be in care. They must be comfortable. Really, Mr. Ziauddin, very good, yeah. It's a type of pervasive distributed systems. So, I suppose that you completely understand what is it. The other example of distributed pervasive systems is sensor networks. Sensor networks. Sensor networks are different type of distributed pervasive systems. But what are sensor networks? I want to give you an example, and with this example you can easily understand the meaning of sensor networks. A good example of sensor networks is this example. Suppose in a forest a large number of sensors. You know what is sensor? A sensor is a hardware that can sense something. For example, in elevator there are some sensors. If you put your hand between the door of the elevator, the door is not closed because the sensor can detect your hand. It is sensor, okay? So, in a forest, suppose a large number of sensors are installed and placed in different locations. The goal of this sensor network is to monitor and track the movement of animals in the forest. For example, we want to know animals usually go to which locations in this forest, okay? So we use these sensors to find. These sensors transfer data wirelessly. They're connected to a network wirelessly. So the sensors transfer and sense data wirelessly. It is sensor network. Was it clear? Good. Characteristic of sensor networks. The nodes to which sensors are attached are many, usually tens, hundreds, or thousands of nodes. They are simple. Small memory, compute, communication capacity. They are small and often battery powered. They use with battery. We do not have electricity power in jungle or forest. Okay, so sensors work with battery. And here you can see two different organization of sensor networks. In the first organization, picture A, we have different sensors in different locations, okay? And each sensor is only responsible to send data to a master, to operator's site, okay? So all the data and all the information is stored in the master, in the server, in the main server. In the second organization, each sensor has some computation facilities and some storing facilities. For example, each sensor is a small computer to calculate something and to store the results in its memory. And then the result is sent to the operator's side. So in this organization, the result, not data, the result is sent to operator's side. In the first case, Muhammad says it is very slow. Can you say why? Why it is slow? Why do you think it is slow in the first organization? Because the processor is one? Okay, but we can have a very strong processor here. The root of a wheel. The root of a wheel is something else. Yes, it's a good answer, but for senses, for second given local server. Okay. I want to say that the problem is very familiar for you. You are familiar with the problem. The problem is about bottleneck. Look at the picture, picture A. We have many sensors. All the sensors are sending data to one server. Okay? There are many data that are being sent to a one server. We will have bottleneck here. In the second case, in picture B, each sensor is a small computer, so only results are sent to operator's side. So in this case, we do not have bottleneck, but we have another problem here. Cost. The problem is about cost. We must use small computers instead of a simple sensor here, okay? So it costs. And also, the other problem is about battery and power. A small computer needs more power compared to a simple sensor in the first organization. In the first organization, we have only one single sensor, so it needs low power energy, okay? But in the second case, we use small computers, so it needs more power consumption. And it's a problem. So it depends on the application, and we can decide which organization can be suitable for us. And congratulations, chapter 1 finished. So in the next session we can start chapter 2. And for before I finish this session, I want to say this part of دعای اللهم اجعلني من أنصاره وأعوانه والذابين عنه والمسارعين إليه في قضاء حوائجه. I hope all of you try to be a good Shia of Imam Zaman alayhi salam. It's really help you. It's really help your life. Believe me. Really try to start an emotional communication with your Imam Zaman. It really changes you, and it's my experience. I can assure you. You can be sure that it will be happen. For simple way, you can start your day with your Imam Zaman. Start your day with a simple salam. Just say, after you wake up, just say, Assalamu alayka ya sahib al-zaman. It's good to start. It's good for beginning, okay? And you can see its results in your life. So now I want to upload a homework or assignment for you. Let me open Darsa website. It's a very simple assignment for you. I'm sure that it's very simple for you. So 1 week can be enough for you to do it. Please do your assignments. They are very important for your mark. Okay, I uploaded it. You can see the assignment in your website, Darsa. Please check it. I want to be sure that it's correctly uploaded. Can you see the assignment correctly? Good. So you have 1 week. 1 week left to do your assignment. Okay. I hope you enjoy your session. Chapter 1 is finished, and I have uploaded the PDF of chapter 1 on the Dersa website. You can use it to review it and summarize it for your assignment. Have a good time, and Khuda Hafiz. Don't worry about your questions and final exam, okay? The exam is all about the slides and my explanations. So I think if you listen to the lesson carefully and you learn what I teach you, you will not have any difficulty with the exam. Don't worry about it. It's easy, okay? خدا حافظ.